In the vast graveyard of the cosmos, there exist objects so extreme they defy the very laws of common sense. Born from the violent death of massive stars, neutron stars are the densest objects in the known universe that we can directly observe. When a star much larger than our Sun runs out of fuel, it collapses under its own immense gravity, triggering a supernova explosion. What remains is a core so compressed that an entire solar mass is squeezed into a sphere roughly the size of a city, only 20 kilometers across. To understand the scale of this density, imagine taking the entire human race and cramming every person into a single sugar cube. A single teaspoon of neutron star material would weigh over 1 billion tons on Earth. This incredible compression happens because the gravity is so strong. It crushes atoms themselves, forcing electrons and protons together to form a solid ball of neutrons. This creates a surface gravity 2 billion times stronger than what we experience on Earth, enough to warp the very fabric of space-time around it. Neutron stars retain the angular momentum of their parent stars, but are shrunk to a tiny fraction of the size. They rotate at blinding speeds, some spinning hundreds of times per second. These are known as pulsars, acting as celestial lighthouses that emit beams of intense radiation from their magnetic poles. Their magnetic fields are equally terrifying, often 1 trillion times stronger than Earth's, capable of dissolving the molecular structure of any matter that gets too close. Some neutron stars, known as magnetars, possess the most powerful magnetic fields in the universe. A starquake on a magnetar can release more energy in a fraction of a second than the Sun produces in hundreds of thousands of years. They are the ultimate laboratories for physics that we could never recreate on Earth. This is Apex Vector. Thanks for watching.